Let's talk a little bit about the composition and the vertical structure of the atmosphere. So the air is a gas that to a very large percentage contains nitrogen and oxygen. More than 99% is nitrogen and oxygen, which are called permanent gases. In addition to that, there are variable gases, okay, which have a low volume concentration, but play an extremely important role in the climate system because they are so-called greenhouse gases. They trap terrestrial radiation and re-radiate energy back to the surface and result in an overall warming of the temperature on Earth. Without these gases, which are water vapor, CO2, methane, nitrous oxide, and ozone, the average temperature on Earth would be minus 18 degrees Celsius. It would be very, very cold. Okay? Water vapor also plays an important role, a part in the water cycle on Earth. Okay, the water cycle has to do with evaporation from the land and ocean surfaces, the formation of clouds, then precipitation, which returns the water back to the surfaces, and indeed continental runoff in terms of rivers, and to a smaller percentage also the groundwater runoff. Okay, on the left side you see the vertical stratification in the atmosphere, the vertical structure of temperature. So the density of air is controlled by temperature and pressure. Okay? Temperature, if you heat up air, it becomes lighter because it expands. And if you reduce the pressure, it also becomes lighter. Okay? So that's why in the lowest portion layer that you find in the atmosphere, which is the so-called troposphere, which captures the weather events that happen on Earth, the temperature and the density of air both decrease with height. Okay, on the left side there's a little sketch. Maximum temperature at the surface, and it's where the heating or cooling takes place. Okay? And then the temperature decreases, okay, until you reach the troposphere, and that's mainly because of the pressure effect. So just important to note there is that in this layer it's not that the density decreases because the pressure and temperature effects compensate each other. Actually the density is pretty uniform in this layer, and this implies that if you heat up the surface you can actually create something we call convection, which mixes the troposphere and can lift up the water vapor received from the ocean or from land surface and lift them up to the top of the troposphere, which is known as the tropopause. Higher up in the atmosphere you can see that the temperature increases with height, and that's the effect that comes from the ozone layer, as a greenhouse gas trapping energy and reducing and causing a heating. And in this zone the atmosphere is stably stratified. The density decreases with height in this layer. Okay.